Hello everyone, my name is Guillaume. I am the team lead on the project qu'une. I'm here today to give you a quick overview of our latest project, so let's dive in. Before going into the segment of this presentation, let's start by doing a quick overview of the rig built for qu'une. For qu'une, we followed a traditional setup suggested by Unity's team. We broke down into 3 sections the way our controllers would interact: grabbable interactors, UI interactors, and teleporters. By doing so, we were able to link each section to its own layer and avoid future conflict. All details are available on Unity's website. As you can see, qu'une is a VR experience game. In qu'une, our users are able to accomplish multiple tasks, from looking around, interacting with objects, interacting with UIs, and also teleport. All those features are possible with the help of Unity's XR interaction toolkit. So let's talk about UIs. A well-known issue with VR is the use of UIs. Many things are to be taken into account: distance from the player to the UI, object interfering with the field of view, motion sickness, and others. For qu'une, we decided from the start to keep it as simple as possible and minimize the risk of having a bad experience. As you can see from the opening scene, we have several options available to us, from creating a new game to accessing the setting panels to exiting the game. By accessing the settings, we are able to set our audio mixer channel volume directly. We also have an additional option to disable all audio sources from the game. You can also see an extra options which enable mature content, which will also be showcased later. As mentioned earlier, a known issue with VR and UI is motion sickness. To avoid any discomfort to our user, we decided to make our UI static. That way, the UI isn't bound to the headset motion tracking. However, by doing so, we were faced with the following issue. Our UI, when activated, doesn't get centered to face our user. A simple fix for that was to retrieve the camera angle, and with a little bit of math, we were able to calculate our menu UI new position according to the headset angle. This way, our user can toggle on and off the UI to recenter it according to the headset motion device. The game modes are set in-game via interaction with world objects, making the experience more immersive and fun. Players are able to challenge themselves through the time round mode, trying to obtain the highest scores, or play casually in regular mode. A practice mode is also available for inexperienced player. Like we said earlier, in qu'une, the player immersion is key. In order to maintain that feeling, we wanted to have the possibility of launching a game through world interaction. By doing this, we avoid having to go back and forth between scenes to initialize a new instance. Another reason for it was also that by handling the instance through the game button, we were able to retrieve and serialize the data inside this single instance, making it easier to load for display, because after all, qu'une is all about keeping scores. Which now leads me to the next topic, serialization. Like every arcade-type game, our game uses a serialization system to save its high score. As we all know, there's multiple ways of serializing data, and almost all of them were tested for this game. An issue we encountered during the development process was the fact that we couldn't append the binary file generated from the binary formatter, which is normal. Since we were serializing each instance when pressing the stop button and appending the file instead of saving all instances inside a list and then serializing it, we had to use a different approach, which is honestly less safer. So we picked a string formatter instead of a binary formatter to save our data, which also involved doing a bit of formatting so that we do not retrieve a single instance loaded from one line and instead retrieve multiple instances laid out on multiple lines. Moving on next to the weapon mechanics.
Hi, my name is Alex, and a large part of my work on Duck Hunt was the weapons and ammo mechanics. The game currently has 4 different weapons that are separated in 2 different types. For example, the pistol and the machine gun are using magazines, and the shotgun and rifle are manually loaded with ammo, which makes the internal behavior of those classes different in some way. Each weapon inherits from the same base weapon class, but further expands into 2 classes with their specific attributes depending on the type of weapon. All the main logic for the weapons are in the base weapon class, and the only specific properties that each weapon has is the shooting sound, reloading sound, the way the ammo depletion works, and also the particles. If the weapon uses a magazine, it is the magazine's ammo itself that will be used upon firing, while weapons that are manually loaded, like the shotgun and the rifle, will deplete the ammo that is inside the weapon. For the magazine, this means that if you drop a magazine that is not empty, you will be able to pick it back up and use the remaining ammo that was left in it when you dropped it. Manually reloaded weapon can be loaded using ammo boxes that have a set amount of ammo in them. To avoid manual reloading mechanics to be a burden for the player, we opted for something as simple as taking the ammo box containing the actual ammo for the weapon you want to use and touch the weapon with the ammo box, and it will be fully loaded, or it will transfer the necessary amount of bullets from the box to the weapon. Should an empty box or an empty magazine be dropped, the object will be destroyed after a few seconds to avoid cluttering the scene and also for, to avoid performance issues with unnecessary items. I have also worked on the mechanics that is used to provide ammo to the player should he need more during a game. So the player will be presented with 4 big ammo crates, each filled with the different types of ammo needed for all the weapons. Should the player use all the ammo in one crate, the ammo crate will simply refill itself, so that player will not go out of ammo during a game. We have also taken into consideration the edge cases where the player could take the ammo, throw it away, or just, accidentally or intentionally smack them out of a box. So as soon as a magazines or an ammo box leaves a crate, the crate will consider it gone and refill accordingly. So once it is empty, regardless if the magazine still exists in the scene, it will refill the ammo crate.
For the duck spawner, I created a prefab where you could set the width, height, and depth of a certain area highlighted by a gizmo draw cube for visual representation. The flow of a round goes as follows. A countdown to the beginning of the round is displayed until the time elapses. Once the round begins, the ducks spawn in waves, spawning from the ground at a random position. They then begin to fly to random positions inside the duck spawner, while steadily incrementing their height, until they either get shot, die and fall to the ground, or reach the ceiling of the duck spawner and escape. The duck spawner logic is predicated by the selection of a game mode. At present, we have 3 game modes: regular mode, timed mode, and target practice mode. Regular mode consists of an infinite number of rounds. Each round has a set amount of ducks to spawn, which come in waves. Each wave can contain 1 or multiple ducks, with a delay between each waves. Each round increment increases the flight speed of the ducks in the following round, up to a determined max round increment. The time mode consists of 1 round. for a predetermined amount of time, set by an in-game time dial. Each wave increments the amount of duck that will spawn in the following wave. After the timer has elapsed, the score is displayed.